Hello, this video is going to be going over our week 4 material dealing with equations. So this first posting that you'll see here, this is the assignment for the LearnStorm, the second week of that. And it's going to be parts 1 through 3 all in one document. Here are the instructions and the questions for each thing. And I'll cover that more in depth in class. But for this video, we're talking about week 4, equations, and here's the PowerPoint I'll be going through. So let's zoom in a bit here. All right, and then I'll be adding the link both on Google Classroom and on the PowerPoint after this video is finished. So preview, we're going to be talking about 3 major topics. 1, combining like terms. 2, how to write an equation given a word problem. And then 3, how to solve some of the basic equations, 1- and 2-step equations. And all of this is a review of 8th grade TEKS, i.e. these were things that were all covered in your 8th grade math class. So combining like terms. Using this, as well as using algebraic representations of items, this allows us to simplify expressions and then do more complicated things with these expressions and equations. Okay? We use different variables to represent different entities. And then here are 3 Khan Academy videos that explore this in increasing detail, in case you need some additional support. For the purposes of this video, here's some examples. So this first one, if I have 1 apple, 2 bananas, and 3 cherries, and then I buy 2 apples, 3 bananas, and 4 cherries, how many of each do I have? And so most of us can probably do this in our head without any kind of algebraic representation help, but this is just to introduce this idea of combining like terms and explaining to you and showing you where we get variables from. Honestly, mathematicians don't like to spend a lot of time writing out a lot of things. We try to come up with shorthand versions of things to represent them more in a more abstract way. So instead of saying this 1 apple, we would say 1A. Okay, and then instead of saying we'll have green bananas, or yellow might show up. Let's try yellow. Instead of saying 2 bananas, we would say 2B. Okay, and then let's make our apples green, and then our cherries can be red. We'll have Granny Smith apples, green apples. Okay. And then instead of 3 cherries, we're going to write 3C. Okay, and if we have something and something else and something else, then we can represent that with addition. Okay, so 1A plus 2B plus 3C. Now, however you look at this in terms of apples, bananas, and cherries, you cannot combine these terms. They are unlike terms. They are not similar. If we were to group them by fruit, for example, then we could add them and we could say that we have 6 pieces of fruit. But talking about apples, bananas, and cherries, they're separate things. So we do not combine these together. We do not wind up with 3 appanas. Okay, we don't wind up with 2 binaries, okay, or 5 binaries. These are different things. They are unlike terms. But here we have 2 more apples, and now we can add these. Okay, 1 apple and 2 apples, that's 3 apples. Okay, so if we have 1 apple plus 2 apples, we get 3 apples. Okay, and bananas. Okay, again, mathematicians don't want to spend a lot of time writing out the word bananas, so we're going to put 3B. Okay, and bananas, these are like terms. They're the same thing, so we can combine these. So we can say 2b plus 3b, and now we have 5 bananas, or 5b. Okay, and cherries. Instead of writing out cherries, we can put 4c. And now cherries and cherries, we can combine those. 3 cherries plus 4 cherries. This gives us 7 cherries. Okay? And since we have all of these things, we have apples and bananas and cherries. We can put the plus signs between them, but then we don't combine them. Okay, 3 apples plus 5 bananas is not 8 bananas. Okay, 5 bananas plus 7 cherries is not 12 banaries. These are 3 different things. Okay, so this right here would be our solution. This would be our simplified expression with the terms combined. Like terms are combined here. Okay, now for this next example, if there's a group of 3 xylophones, okay, I don't want to write xylophones over and over again, so I'm going to put 3x. Okay, being played by 1 yak. Okay, I'm going to put 1y and 2 zebras. I don't want to write out zebras a bunch of times, so I'm going to put 2z. Then it says, how many of each will we have if we add 2 more similar groups? Okay, so now we're talking about grouping. We can think about parentheses. Okay, this is going to be 3 xylophones plus 1 yak plus 2 zebras. 3x plus 1y plus 2 zebras. Okay, and then if we're going to add 2 more similar groups, then we can go plus, okay, plus, okay, and then plus, 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 plus. All right. And then we've got, there's similar groups, so each one's going to have 3 xylophones, or 3x. Okay. And each one's going to have 1 yak, so 1y. And each one's going to have 2 zebras, so 2 zebras. And now we can combine all of this. 2 zebras plus 2 zebras plus 2 zebras. That's going to be 6 zebras. And 1 yak plus 1 yak plus 1 yak, that's 3 yaks. And we have yaks and zebras, so we can add those. And we have 3 xylophones plus 3 more, so that's going to be 9x, or 9 xylophones. Okay. Now, xylophones plus yaks, we don't wind up with xylax. Okay, they are separate entities. We've combined our like terms, and now we're done. This is our simplified expression. Okay. All right, I'm going to pause the video and erase the screen here. All right, moving on. Writing equations from word problems. Okay, so we take a word problem, a scenario, maybe a paragraph or a couple of sentences, and we can distill that into an algebraic representation. We can write an equation from that scenario. And it's a very powerful tool to help us do a lot of things without the words encumbering us. You know, having to write xylophone 20 times if we have 20x, for example. And here's a couple of videos on Khan Academy that explore this further. Okay. So right here we've got, if I have 1 apple, 2 bananas, and 3 cherries, and then I buy 2 apples, 3 bananas, and 4 cherries, how many of each do I have? It says to write an equation to show this scenario. And the second one says, if there's a group, should say of 3 xylophones being played by 1 yak and 2 zebras, how many of each will we have if we add 2 more similar groups? And then write an equation to show this scenario. So I encourage you at this point to pause the video and try these on your own. Okay, hopefully you paused the video and tried these. So let's see what we got here. So as before, our 1 apple, that's going to be 1a. Our 2 apples, that's going to be 2a. Our 2 bananas is going to be 2b. 3 bananas will be 3b. 3 cherries will be 3c. And 4 cherries will be 4c. Okay? And so I had this starting amount. Okay, I had this 1 apple, 2 bananas, and 3 cherries. And then if I buy more of them, then I'm going to be adding them. So I'm going to be adding. And there's many different ways to write this equation. So if you wound up with one that looks a little bit different, don't worry about that. But make sure it has the same idea. Okay, so this is our starting value, this first parentheses, and then we're adding what we're buying here. This is going to be very similar to what we did on the previous slide. This is just showing it in equation form. So we're going to have our 1a and our 2a and our 2b and our 3b and our 3c and our 4c. Okay. And now we can combine our like terms. Okay. So we've got 1 apple and 2 apples. That's going to give us 3 apples. And our 2 bananas plus 3 bananas will give us 5 bananas. Plus our 3 cherries plus 4 cherries will be 7 cherries. And we're done. Okay. And then for the xylophones, zebras, and yaks, we've got our initial set here. We've got our 3 xylophones, 3 X's, with 1 yak, 1 Y, and 2 zebras, 2 Z. And if we're adding 2 more similar groups, in the previous example I showed it by actually adding 2 other groups, but if we're adding 2 more groups, that means we're going to wind up with 3 groups total, which means really we can just multiply this initial group by 3. Okay, and so when we have a coefficient to our parentheses or grouping of some kind, that means we need to distribute, okay, distributive property to everything in there. This is 3 groups of this. So 3 groups of 3 x's, that's going to be 9 x's. And 3 groups of 1 yak, that's going to be, whoops, that's going to be 3 yaks. And 3 groups of 2 zebras, that's 6 zebras. And this is exactly what we got on the previous example where we did it by addition rather than multiplication. As I mentioned previously, many ways to set up and solve these equations. And as long as the way that you set it up is valid, then you're fine. All right, I'm going to pause the video and erase the screen here. All right. Solving one-step equations. So to solve equations, we're generally going to use the order of operations in reverse. Okay, for the simplest equations, we can do this in 1 step. So here's some videos on Khan Academy to help you understand this better. But basically, you need to think of an equation like a balance scale. And whatever we do to one side, we need to make sure to do to the other so that it stays balanced. So in this first one, we've got a plus 7 equals 13. So we need to figure out what do we need to add 7 to get to 13. What plus 7 equals 13? Well, in these simple type examples, you might already be able to just think of that, and you might realize that it's 6. But the mechanics behind it, and we need to learn this so that we can handle the more difficult equations, is that we want to undo whatever's happening to the variable. So right now we're adding 7 to it. So the opposite of that is going to be to subtract 7. But whatever we do to one side, we need to make sure that we do to the other as well. Okay. And so right here, 7 minus 7, that's just going to be 0. That cancels out. So all we're left with on the left side is going to be a. And then that's going to equal 13 minus 7, which will be 6. Okay. This next one, we've got some variable b, and we need to subtract 7 from it to get 13. So what can we subtract 7 from to get 13? You may have already noticed what the answer would be, but we need to practice the mechanics of it. So the opposite of subtracting 7 is going to be to add 7. And again, whatever we do to one side, we have to do to the other. And right here, negative 7 plus 7, that's going to give us 0, so that cancels out. And we're just left with b equals 13 plus 7 is 20. Okay. So now I encourage you to pause the video, take a few minutes, and see if you can solve the rest of these on your own. Alright, so hopefully you've taken a look at these on your own. So remember that we need to undo whatever's happening to our variable, get it by itself. Okay. So right now, on this third one, we've got a variable c that we're multiplying by 7. So the opposite of multiplying by 7 is going to be divide by 7. And whatever we do to one side, we need to do to the other. Okay, 7 divided by 7, that cancels out to 1. And 1 times c is just c. And then 13 divided by 7, we can just leave that in fraction form there. Okay, 13 sevenths. Okay. And then d divided by 7, the opposite, the inverse operation of dividing by 7 would be to multiply by 7. So we're going to take all of this and multiply by 7. And so we'll need to do the same thing to the right side as well. And then these will cancel out. And we'll be left with 1 times d, which is d, equals 13 times 7, that'd be 70, 91. Alright. Now, on this next row, we've got the variable on the right side. It doesn't change how it works. We still want to get the variable by itself, and we still need to do the same thing to one side as the other, and we're still looking for inverse operations so that we can isolate our variable. So the opposite of adding 13, that's going to be subtracting 13, the inverse, and so we'll do that to the other side as well. And then 13 minus 13, that cancels to 0. So on this right side, we're just left with e equals, and then 7 minus 13 will be negative 6. All right. And so at this point, I encourage you again to pause the video and solve the rest of these if you haven't already done so. All right, so hopefully you've tried the rest of these on your own. The opposite of, or the inverse of subtracting 13, that's going to be plus 13. What we do to one side, we do to the other. And we're going to wind up with f is equal to 20. And the opposite or inverse of multiplying by 13 will be to divide by 13. What we do to one side, we do to the other. So we'll wind up with g equals 7/13. Okay. And the opposite of dividing by 13 will be to multiply by 13. And we'll do that to both sides. So we'll wind up with h is equal to 91. And 13 minus w equals 7. Here we've got a bit of an interesting situation. There's a few ways that you can go about answering this, just as with any other equation. But you may find that adding w to both sides may help. Okay. And subtracting 7. Okay. So we'll move the 7 to the left and the w to the right. Now doing it this way technically makes it a two-step equation, but it can be done other ways as well. But I just want to highlight and show you what's going on here. So if we add w right here, okay, w minus w, that cancels out to 0. So on the right side, we're left with w. And 7 minus 7, that cancels out to 0. So it's just the w on the right side. And then this equals 13 minus 7, which is 6. Okay. And then for this one, we're adding 13. The inverse of that, the opposite, would be to subtract 13. Do that to both sides. And we're left with x is equal to -6. And the opposite of multiplying by 13 is to divide by 13. And what we do to one side, we do to the other. 13 divided by 13 cancels out to 1. 1 times y is just y. Equals, and 7/13 is already simplified. And then finally, dividing by z. This one actually is a two-step equation, and I included it on purpose to help lead us into the next section, which is our two-step equations. So dividing by z, the opposite of that is going to be to multiply by z. And what we do to one side, we do to the other. Okay. Z divided by z cancels out, so we're left with 13 equals 7 times z. And now we can do the inverse of multiplying by 7, which is to divide by 7. Do that to both sides, and we are left with z equals 13/7. All right, I'm going to pause the recording and erase the screen here. All right, and then two-step equations. To solve equations, again, order of operations in reverse. What we do to one side, we do to the other. Here's some additional videos on two-step equations on Khan Academy. And then here we have some two-step equation problems to practice. And so remember that we want to do the order of operations, but in reverse. So instead of going from parentheses to exponents, to multiplication, division, to addition, subtraction, we're going to go the opposite way. Okay, because we're trying to undo it. So we want to go in reverse. Okay, think about dressing versus undressing. You put your clothes on a certain way, you probably take them off in reverse. Okay, think about tightening a screw. You screw it one direction to tighten it, and you screw it the other direction to undo it. Okay. So the opposite of adding 7, the inverse, is going to be subtract 7. Again, what we do to one side, we do to the other. 7 minus 7 cancels out to 0. So we're left with 2a equals 6. And then the inverse of multiplying by 2 is going to be to divide by 2. What we do to one side, we do to the other. And we wind up with a is equal to 3. And I just noticed I switched to lowercase a instead of capital A. That's all right just for this video. Okay. So now pause the video and try the rest of these on your own. I'm going to pause the recording as well and finish this row. Then I'll unpause it for a few seconds, pause it again, do the second row, etc. So at least try this first row first. All right, so hopefully you would pause the video and try the first row on your own. So you can see that on the second one, the inverse of subtracting 7 is to add 7. We do that to both sides. We wind up with 1/2 b equals 20. And if half of b equals 20, then the full b equals 40. So that's like if you've got this box here, and this whole box is b, if half of that is 20, that means the other half's 20, which means the whole thing is 40. And on the third one, we're going to subtract 2 first from each side. So we wind up with c times 7 equals 11. Inverse of multiplying by 7 is to divide by 7. So we wind up with c equals 11/7. And for the last one of this row, we add 7 first to each side. We wind up with d divided by 7 is equal to 20. And then we multiply by 7 on each side, and we get d equals 140. So at this point, go ahead and pause the video again and see if you can solve the second row on your own. And I'll pause the recording as well, and then when it resumes, it will have that row solved. All right, hopefully you would pause the video to try these on your own. So let's check our work here. On the first one, we want to subtract 13 from each side and then divide by 2 to wind up with e equals -3. On the second, we want to add 13 and then multiply by 2. We wind up with f is equal to 40. On the third, we want to subtract 6 first and then divide by 13. And we'll get g is equal to 1/13, 1 over 13. And on this last one, hopefully these parentheses didn't confuse you. Remember that we need to go in reverse order. So in this case, division comes before parentheses. Okay. So we need to do the inverse of divide by 13, which is multiply by 13 to each side. We get h plus 2 is equal to 91. And then we can subtract our 2. We wind up with h is equal to 89. Okay. So if you need to write these down or change anything, pause the video and do that. Now I'm going to clear this row, and I encourage you to pause the video again and try the last row on your own. And I'll pause the recording as well, and when it resumes, it will have those solutions as well. Pause the video and try it on your own. All right. So this first one, we want to divide by 2 first. Okay. Normally parentheses come before multiplication, but remember we're going in reverse order. And so we'll get 13 minus w equals 7/2. Okay, and then we can add w to both sides to cancel this w out and get w on the right side, and subtract 7/2 from both sides, and we will wind up with 9.5 equals w. And then we want to subtract 13 first on the second one, and then multiply by 2 to get x equals -12. On this third one, we want to divide by 13 first, and then we'll get 2y is equal to 7/13. And then we divide by the 2 to get y by itself. And 7/13 divided by 2 is going to be 7/26. And if you need a review of dividing fractions, this is how it worked out. Okay, so dividing fractions, really all you need to do is flip the second and multiply. Okay, dividing a fraction is the same as multiplying by its reciprocal. Or a handy rhyme, dividing fractions, easy as pie, flip the second and multiply. Not exactly rigorous, but it works to help you remember that. On the last one, we subtract 2 from both sides and multiply by z, and then divide by 5 to get z equals 13/15. And then this one's technically a 3-step equation, but again, I like to end with a little bit harder problems to get you prepared for more rigorous things that follow. Okay, so I'm going to clear the screen here, and then we'll come up to our summary. I do wish there was a click to clear button. All right. Putting it all together. Okay, so here's some videos that go over how to do all of this at once, as well as a challenge problem, 2 challenge problems rather. So if I had 1 apple, 2 bananas, and 3 cherries, and then I bought 2 apples, 3 bananas, and 4 cherries, and then I share these equally with 2 friends, how much do each of us get? Write an equation to show this scenario, and then solve. Okay. And then there's a group of 3 xylophones being played by 1 yak and 2 zebras in the park. Some other yaks and zebras decided to join, and then there were triple of the starting group. However, the starting group had been playing for a while and decided to go home. Write an equation representing this scenario and solve. So I encourage you to pause the video and try these on your own, and then I will pause the recording as well, and when it resumes you will see solutions to these. Alright, so hopefully you had tried these on your own. Here are the solutions, along with at least one way to work each of them out. There are multiple ways to have worked them out. But the way that I proceeded through this first one was I wrote down the initial scenario, 1 apple plus 2 bananas plus 3 cherries. And then I added what I bought, the 2 apples, 3 bananas, and 4 cherries. And then I got a total of 3 apples, 5 bananas, and 7 cherries. And then these were divided with 2 friends. Okay, equally with 2 friends means myself and 2 friends. That's 3 people. So divided by 3. Each of these is divided by 3. That means that each person gets 1 apple, 5/3 bananas, which is almost 2 bananas, and 7/3 cherries, just a little bit over 2 cherries each. Okay. As I said, multiple ways to have set up the problem in the equation, but however you had set it up, if you solved correctly, you should wind up with this here. And then for the second scenario, we've got 3 xylophones, 1 yak, and 2 zebras. And then with the other ones joining, we wind up with this situation right here where we would multiply it by 3 to triple it. Okay. But the original group went home, so we subtracted 1 group. And so we wind up with 2. We wind up with double instead of triple. And so now we just distributed that 2 to each of these terms, and we wind up with 6 xylophones, 2 yaks, and 4 zebras. So hopefully you found that helpful, and hopefully you went along with the video and paused and tried the various things on your own. when you are in a class, you can interact with others and ask questions and such, but when you're watching a video, it can be harder to engage with it, and that's why you need to pause the video occasionally and try things on your own and interact with it to engage with the material. So in summary, we reviewed just combining like terms, how to write an equation given a word problem, and how to solve 1 and 2-step equations. Things to remember: combine your like terms only, not your unlike terms. Okay, we don't want any abanas or any binaries. Okay, combine your x's with x's, y's with y's, m's with m's, units with units, etc. The order of operations is used for solving expressions, but equations generally are solved in reverse order. We are trying to undo operations, so we need to do the reverse. And then an equation is like a scale, and it must be balanced at all times. Whatever you do to one side, make sure you also do to the other. I hope this video was helpful. If you need more support, make sure to check out all of these Khan Academy videos that I have linked, and they have excellent practice exercises as well, or come to tutoring. All right, bye.